Hello, grade 5, and welcome to session 1 of our new lesson, which is characteristics of quadrilaterals. This is lesson 14 in our book, which is page 93. We have many objectives in this lesson, which are recognizing the diagonals of a polygon, recognizing the properties of some quadrilaterals, and how to recognize a quadrilateral according to its diagonals. First of all, let's talk what is a quadrilateral.
Screen, an
A
envelope,
screen,
or a canvas
an
are all examples of
envelope, or
quadrilateral.
a compass, these are
Quadrilateral is
examples
one
of
word, but you
quadrilaterals.
can see that this part
Quadrilateral
is colored red
is a one
and
word,
this part is
but as
colored
you can
blue.
see, one is
Quadri
colored
basically
red
means
and
four
one is colored
and
blue.
lateral means sides.
Quadrilateral, quadri means
If you
four and
observe,
lateral
all
means
these things
sides.
have four
If
sides.
you
This
observe,
is an example
these
of a
shapes have
quadrilateral.
four sides.
To name
This
the
is an
quadrilateral,
example
we
of
give names to
a
these 4
quadrilateral.
points.
We
We call them
name a
A, B,
quadrilateral
C,
using these
and
4
D.
points A, B,
These things
C,
that we
D.
just named are called
These points
vertices,
are called
and a quadrilateral
vertices,
will always have
and a
4 vertices.
quadrilateral has
Each
always
point is
4
called a
vertices.
vertex.
Each
And as
point
we've
is
already
called a
seen, a
vertex.
quadrilateral
A,
has 4
B,
sides,
C, and D is
and the
a
sides are
vertex.
called AB,
And each
BC,
quadrilateral has 4
CD, and
sides, A,
DA.
B,
So
C, D,
remember,
and
every
D,
quadrilateral has
A.
4 sides
Each
and 4
quadrilateral
vertices.
has 4 sides and 4 vertices. So, what is a quadrilateral? A quadrilateral is a closed shape that has 4 sides. Okay, these are examples of quadrilaterals. So, what is a quadrilateral? A quadrilateral is a shape that has 4 vertices. The points are called vertices. Vertices is a word plural of the word vertex. One is a vertex. 4 are called vertices. A quadrilateral has 4 sides. These are the sides of the quadrilateral. The sides are joining two consecutive vertices. They come after each other. And a quadrilateral has 2 diagonals. What is a diagonal? Look at the figures below. The yellow segments are called diagonals. The diagonal is a segment joining two opposite vertices. Since it's joining two opposite vertices, so I will get an X shape, so I will get two diagonals. In each quadrilateral, I have two diagonals. They have X shape. They are joining two opposite vertices. Opposite, they are facing each other. Okay? This is a vertex. This is a vertex. This is a vertex, and this is a vertex. They are called four together vertices. This is a diagonal, and this is the side. How to name a quadrilateral? The vertices of the quadrilateral, the sides, and the diagonals. To name any shape or to name a quadrilateral, we use its vertices. So to name this quadrilateral, I have to use the vertices. It's called A, B, C, D. Okay, I go to the consecutive vertices. Okay, A, then B, then C, then D. Or you can start from B, it's B, C, D, A. Or you can start from D, it's D, A, B, C. This is a quadrilateral A, B, C, D. How to name the vertices? The vertices are points. This is vertex A. This is vertex B. This is vertex C. and this is vertex D. It has 4 vertices. How to name the sides? The sides are segments joining 2 points, joining 2 consecutive vertices. So this is segment AB. I use brackets to name a segment. This is side BC. This is segment CD from point C to point D. This is segment AD or DA. Similarly, if I want to name a diagonal, diagonal joining 2 points which are AC. So this is diagonal AC and this is diagonal BD. We use brackets to name segments. So we use brackets to name diagonals and sides. Okay, let's take an example. ABCD is a quadrilateral. It has 4 vertices and it has 4 sides. What are the sides of this quadrilaterals? AB, BC, CD, and AD. It has 4 sides. Its vertices, the points are A, B, C, and D. The diagonals are AC and BD. And if you can see from the figure, AC and BD, the diagonals intersect each other. They meet at a point I, this is I, the point of intersection of the diagonals. Let's make another application. Observe these polygons and choose the correct answer. The shape of figure 2. Figure 2, let's look at figure 2. Is it a quadrilateral or it's not a quadrilateral? Look at the sides. They are 6. So it's not a quadrilateral because the quadrilateral has 4 sides. In figure 1, AM, is it a vertex, a side, or a diagonal? AM is joining 2 consecutive vertices, so it's a side. Look to figure 3. This is figure 3. AM, AM, is it a vertex, a side, or a diagonal? AM, it's joining an opposite vertices. 2 opposite vertices, so it's a diagonal. What is the other diagonal in this quadrilateral? It's SH. Okay, let's continue. Go to figure 1. This is figure 1. What are the diagonals in figure 1? The diagonals are AH and BM. They make X shape. These are the diagonals of the quadrilateral ABHM. The quadrilaterals that we are going to study their properties are square, rectangle, rhombus, and parallelogram. We are going to identify the characteristics of the diagonals of these quadrilaterals. So let's start talking about the characteristics of the diagonals. Let's take this diagonal KM. It's a segment. Look, I have chords. OK is equal to OM, coded properties. So O is in the middle between KM. We can say that O is the midpoint of KM. Here I have measures. AR is 4 centimeters. RB is also 4 centimeters. So AR is equal to RB. R is in the middle of AB. So we call R the midpoint of AB. Mid is from the word middle. Midpoint is the point in the middle. Now, let's take these two diagonals. Look at the black segment AB. Look to the right of C. CB is equal to CA. Coded properties, they are given equal from the codes. They have same codes. So, C is the midpoint of AB. Look at the red segment, which is DE. Up, CD is equal to down, CE. They have same codes. So C is the midpoint of DE. So the two segments meet each other at the same midpoint. Okay? We say that any two diagonals, they make X shape, just like the X. They are intersecting. In this case, they are intersecting in their midpoints. So what can we say? We can say that these diagonals bisect each other. A, B, and ED bisect each other. Why? What is the meaning of bisect? Bisect means they meet each other, they intersect where at the same midpoint. So when I have any two segments or any two diagonals which are intersecting at the same midpoint, I call them they bisect each other. Bisect means intersect each other at the same midpoint. Okay, but what if I have these two diagonals? They don't intersect at the same point. Look, O is the midpoint of AS, but O is not the midpoint of RM. Look, OR is not equal to OM. Can I say these two diagonals bisect each other? No, AS and RM, they don't bisect each other. They just intersect. Okay, they meet each other, but they don't bisect because they don't intersect at the same midpoint. Oh, look to this case. These two diagonals, look, OB is 5. OA is 5. So O is the midpoint of AB. OB E is 5. OD is also 5. So O is the midpoint of DE. So these two diagonals bisect each other. Okay, they have the same midpoint. But look again. 5 and 5 give me 10. 5 and 5 give me 10. So AB is 10 and DE is 10. So these two diagonals are equal. So I add one property, as you can see here. These two diagonals, I can say that AB and DE, they are equal. They are equal in measure or equal in length and bisect each other. They have the same midpoint. So, as you can see, some diagonals bisect each other, some diagonals are equal and bisect each other, some diagonals, they don't bisect each other. Okay, how can I know? I can know from the given properties. Okay, so let's make an application on the diagonals. Look, what can you say about these two diagonals? They have the same codes, so they bisect each other. Are they equal? If this one is 4, absolutely this one is 4, and this one is 4, and this one is 4. They are equal in length. Look at the second one. Up is equal to down. Right is equal to the left. So they have the same midpoint. But are they equal? Here we have two dashes. Here I have one dashes. They are not equal. Look at these two diagonals. Up is equal to down, but right is not equal to the left. So they don't intersect at the same midpoint. They don't bisect each other. Are they equal in length? No, they are not equal in length. By this, we finished our session. Thank you for watching. Goodbye.